Welcome to our video tutorial of the box principle. In this tutorial, we will look at three problems, the most common problems that we deal with when considering the box principle. Look at the first problem as it appears on your screen. The first thing we need to do is identify the boxes and identify the pigeons. In this case, we are grouping people based on the month in which they are born. The boxes a lot of times are the categories in the problem. We're grouping by the month they are born, so the boxes are going to be the months. The other aspect of the problem becomes the pigeons. So in this case, the pigeons are going to be the people. But notice that we don't know how many total people there are. Yet, we want at least 50 people to be born in the same month. When doing this, we must use the worst case scenario. And the worst case scenario is simple. What's the most people that could be gathered and yet have our question be false? Well, if we had 49 people born in each month, this question would be false, and that would be the most people for the question to be false. So we take 49 people per month, our worst case scenario. We multiply it by the number of months, which is 12, and that's how many people could be in the room and yet still have this question be false. With even one more person added to the mix, we now guarantee that the question is true. So the answer to this problem is 589 people gathered in the auditorium would guarantee at least 50 were born in the same month. This is the process you would always use when the total number of pigeons is unknown. Let's consider our second problem. It is currently pictured on your screen. Ooh, this is exciting. We have 3,000 people attending a high school football game. We know the total number of people. How many of these folks must agree on the same favorite day of the week? Now, as we said in class, yes, all 3,000 of them could have the same favorite day of the week, but that's highly unlikely. So what we're going to do is we're first going to identify the boxes and the pigeons. Again, the boxes are the categories, how we're grouping people. In this case, we're grouping them by their favorite day of the week. So the boxes are going to be those days. The pigeons in this problem are the people. We know how many total people there are. So there are 3,000 of them. Now, the worst case scenario still applies. It's a little bit different though. Yes, all 3,000 people could agree on the same favorite day of the week. But if we want to be sure we know how many of them must agree, we need to divide those people evenly amongst the boxes. So when we divide them, the 3,000 people, evenly among the 7 boxes, that's our worst case scenario. In this problem, it turns out to be about 428 and a little bit more than a half a person per box. So each of the 7 days in this worst case, evenly divided scenario, each of the boxes has 428 people in it. However, be careful. Since there is at least one more person in the mix, we automatically round up. They will be the 429th person for one of the boxes. And therefore, we can guarantee that at least 429 people are going to agree on the same favorite day of the week. It could be more, but we would be able to guarantee 429 people do agree. And now our third and final type of problem. It's a little bit different. In this case, we are selecting 6 numbers from a list. We want to show at least 2 of them must be consecutive. Well, first we start off with our boxes and our pigeons. And our pigeons we initially say are the 6 numbers being selected. From that, we determine how many boxes. If we have 6 numbers, we want 1 fewer box, so that's going to tell us we want 5 boxes. So now we're going to draw 5 boxes, and we're actually going to build them. Well, not literally, physically, but we are going to form what each of the boxes are. To do that, we want to use each of those numbers in a box, and we only want each of the numbers assigned to one of the boxes. We're aiming for consecutive numbers. So in the first box, I'll put 1 and 2. They're consecutive. But if we put 2 and 3 in the second box, then we've reused the 2. We don't want to do that. So instead of 2 and 3, we can put 3 and 4. Then we'll put 5 and 6. Again, they are consecutive, and we're not reusing a number. 7 and 8. And finally, 9 and 10. Now, you would need to write a little explanation as to how this works. So say something along these lines. Since there are 6 numbers being selected and only 5 boxes, the box principle will guarantee at least 2 numbers come from the same box. And based on how we built those boxes, those numbers are consecutive. Thank you for watching, and that was the box principle.